Hello guys, today I have come with a new function block which I have developed on the PID function, and this function block is developed on the Works3 platform of Mitsubishi Electric for IQ-F and IQ-R. This function block is separately available on request for IQ-F and IQ-R. So let us start. So just see, this is the PID function block which is seen here. This PID function block is having some inputs and outputs, the details which I am going to explain in the future slides. So this is the PID function faceplate which is proven on the GOT. That is, this screen is developed on the GT designer of the Mitsubishi Electric software, and all these parameters which are seen here, these are the inputs and the outputs for the developed PID function. So the control system is divided into the three zones: the ramp zone, the core zone, and the fine zone. Control zones are defined on the basis of difference between the actual temperature and your set temperature. Here, for the example purpose only, I am defining the complete function block on the basis of temperature control. So it is not an issue to use this function block for any other control type of features. Like if you want to control the pressure, if you want to control the flow, this function block can be used. So the control zones are defined on the basis of the difference between the actual and the set values, set temperature, whatever you can say. The P gain defines the change in the CV percentage. I time, this is the I time. Again, the thing is that above is P gain. P gain is the percentage of the CV percentage. Then I time defines the delay time in between the P gain changes, and the D time defines the duration of the time the CV will get it applied. The forward control and reverse control methods are configurable based on the type of control you are actually looking for. For example, like if your set temperature is 100 degrees and your actual temperature is say ambiently 30 degrees, so now your temperature will be controlled below the set value. In this case, your forward control mode will be activated, and you have to select the forward control for such type of controls. That means the difference, once the difference will get it lesser towards the set point, the output will get it vary to maintain the temperature or maintain that particular variable below the set value. For reverse control, this will be on the vice versa case. That means if your set value is, like if your set value is 5 bar and you want to maintain the pressure of a chamber by reducing some control, by controlling some control wall or something like that, to get down the pressure towards the 5 bar. That means if your environmental or that chamber pressure is somewhere 9 bar, and if you want to get it down towards the set value of 5 bar, so in that case your reverse control method will be applied. In a case where if you are looking for both type of control methods, both things, this thing can also be configured inside the function. So this is the control philosophy. Now let us see the CP Now let us see. Now the SP is here, it is 150 degrees, and my PV is increasing through 90 degrees, through 110 degrees, through 140 degrees, and it will try to achieve the 150 degrees. So in this case, if I define my ramp zone as 60 degrees, so the ramp zone values of P, I and D will applied above the ramp zone temperature. If you, once the temperature increased as per the varying CV percentage, when you cross 90 degree of temperature, means in this case, once you cross the 60 degrees difference and you when your temperature enter between this, that means when your temperature rises above 90 degrees, then your coarse zone operation will get start, and the P gain, I gain and D gain values will get applied. In the same manner, the fine zone will come into action when your actual temperature will increase above 110 degrees, 110.1. So for this philosophy, once the temperature will increase up to 140 degrees, that means your fine zone starting point. At this particular point, the control function block will stop the control value, that CV percentage, and it will leave the system on its own behavior. Now for this let's say example, while you are cooking something on your gas somewhere, so if you turned off your gas, still even for some time you are able to cook your food. So up to these points, up to this 140 degree, I kept on my this what you can say, the burners at different values. But after this value 150 degrees, I am turning off my burner and my supply is now zero. So on its natural, on its phenomenal behavior, the temperature will still increase up to the set value, and it will go up to the value as per the environmental conditions, and from there it will again coming down as per the, since I am not giving anything any burning philosophy behind from that. So in this case, this fine zone value will be your very fine value. That means this will define the surge value above the set value. So all these values has to be very carefully set for the precise control of the function block. For example, on a particular machine, when it was when we were proving this, the temperature set value was 150 degree, and on the basis of these P and ID values, my temperature was maintaining, and it was maintained at 149.5, 149.6, and it was not going above that particular value. That means since these values were sufficient to maintain the temperature nearby to 150 degrees, so my PID was working so precisely. So the inputs are, you have to apply the set value. This will be real 32 type of variable. The process value, your input value, the temperature value or whatever you are using for to get it controlled. This will also a real 32. The gain value, The gain values will be in the form of array. That means for the 0 entry, this P gain will be applied for the ramp zone, the second one will be applied for coarse zone, and third one, the array number 2, will apply for the fine zone. Similarly, I and D values will also be applied, separately applied for the ramp, coarse and fine. When you come to the configuration, now see, if you want to, if you want a control, forward control, you have to set the value of this configuration as 1. If you want a reverse control, you have to set this value to 2, and in case of both control, you have to set it to 3. So this is as per your application. The settings, this float setting values are your zones values. That means this 0 will be for the ramp zone, 1 will be for the coarse zone, and 2 will be for fine zone. These are the status outputs from the function, that is the error between the set value and the actual value, the correction value in terms of 0 to 100%, the actual process value which is coming from the input. Now these status words are that 0 bit is defined for the zone settings are accepted, forward control is selected, reverse is selected. It is these 3 to 13 are reserved for the programming purpose, and 14 and 15 are for the warning and errors. Similarly, what all type of warnings you can have, what type of, okay, and these are the basically the main control outputs from the function block. So thank you very much, and as I already told you, contact us for the libraries in the IQ-F platform and IQ-R platform separately. On the basis of your details and on the basis of your PLC selections, we will provide you separate function blocks for IQ-F, that is for the FX5U PLCs, and for the IQ-R platform PLCs. So guys, thank you for watching. If you like this video, kindly subscribe, and thank you for this. Thank you very much. Bye.